All right, let's get the strain wreck rolling. So, after two failed attempts to make a video on. Hold on here. Yeah. Let's get all this cleared out because I have no idea what I'm doing here. Alrighty. So, HP tuners, I've seen a few things coming up about. About HP tuners, whether or not it's any good for drivability diagnostics. Is it worth the $300-400, whatever it may be? So, tried recording a couple videos, kept bungling them. So, we're going live and making an even bigger mess of it. So, right here, this is the MPVI2, the most recent HP Tuners dongle. And this is actually your license everything for the software. So the software itself, much like the Pico software, for the VCM scanner and the VCM editor, they're both free. You can download them, you can read other people's log files, read other people's tune files, do whatever you want to do with them. As far as being able to actually use them on your own for graphing, editing, tuning, whatever, that's where this guy comes in. I have tried with a couple different VCIs after I enabled the software, put my registration key in and all. Didn't have much luck. But once again, it's like $300, I think, for the kit. So it's well worth it. You got a auxiliary input here. And what this side USB is it'll allow up to 4 analog or digital inputs. For most of what we're going to be doing automotive drivability concerns on OBD2 vehicles, you're not going to need it. That was more designed to have additional sensors you could put in there and interface with it for carbureted vehicles, early throttle body injected vehicles, things along those lines. On the other side here, we've got our little Bluetooth pairing button, and then we've got a USB-C connector. It actually comes with a USB-C to USB-C cable. If your laptop's equipped with that, great. If not, any USB to USB-C adapter will work. The speeds are pretty much the same from what I've found. So, what we've got set up on the bench here, at least for demonstration purposes, is a 2009 Toyota Corolla ECU. And what we're going to be doing there is it just makes it easier to show you guys how to connect. And then we'll go through some old log files and all that I have so you can see some of the capabilities. So let's switch me off the big screen because I don't like being there. And we're going to plug this into our breakout box. And right here, when you first open up the VCM scanner for the first time, this is the general layout you are going to get. So we've got log file, vehicle layout tools, help bar, all that up top. You'll see here we've got something named channels, which is our data PIDs. Right now, we're currently loaded with what they're calling the SAE defaults. So it's data channels that HP Tuners has found to be useful to everybody. I mean, it's pretty basic stuff. It's not super exciting, but that's all right. You'll see right here we've got what looks like your standard Snap-on, Alltel, launch, data graphing set up on the screen here. We've got all that. We can go to our Excel style spreadsheets, which graph over time and give a more comprehensive picture. And then we can flip right over to our gauges here. And I got my background set already, but this is our stock gauge setup. So you'll have MAF, MAP, RPM, speed, intake air, engine coolant temp, short and long-term fuel trims, injectors, O2 air fuel ratio, knock retard, advanced TPS. These are all just your generic out-of-the-box settings. Everything within this VCM scanner is completely and totally configurable. So what we can do here is if we go up to this top bar just to show you some of the pre-laid out stuff, we're going to go to layouts. We can go here and default layouts. So we can do default layouts based off of a millivolt reading for O2. And all these readings are done through generic OBD2. This is not enhanced or manufacturer side. But we could do millivolts, air fuel ratio, lambda. So let's just do multi-window, O2 millivolts, mass airflow engine. So this will give me some predetermined data PIDs. Everything's set up. A lot of fun, right? We don't really care. This is all the basic beginning stuff. Let's switch right over. We're going to connect to this vehicle. So right up top here, we choose our connect to vehicle button. It's going to run through, and you'll notice our channels tab has changed here. We've got a few grayed out data parameters that are no longer showing. So what they're actually doing is HP Tuners has shown that specific data PIDs they're looking for here are no longer there. Or it's under a different network address. We won't get into the CAN part of it. But if we wanted a real quick, simple out the door, we hadn't configured tables, we'd go right up to our channels in the folder, and we would open, say, vehicle defaults. And that would give me HP Tuner's pre-configured list of vehicle defaults, everything they think is important to evaluate the drivability and the performance of this engine. It's all right, but if we go over two of them to this little gear icon, we can go to add channel. And when I add that channel, you'll see we've got two main options here, two main windows. We have OBD controller, which is our actual direct ECM. And then we have our external inputs, which is going to be that 4 analog digital USB cable that goes into the side of it. So there we could add a couple different inputs voltage wise. We can actually use the serial port on your laptop. If your laptop does have a serial port, you could add some additional stuff there. They've got it all pre-configured. And you can add and subtract for the external stuff pretty much as you would like. What we want to focus on as diagnosticians is this OBD controller. So let's go through and see what data PIDs we do have available. So we'll start with engine. Right here. So you'll notice how we've got a blued out data PIDs here. These are ones that are already on this channel list. So general drivability, say you've already done your temperature plausibility checks, you've made sure ECT, IAT, MAT, ambient air are all within a couple degrees of each other. Key on, engine off, cold engine, right? So I'm going to pull engine coolant temp out of this. Come on. Or at least attempt to. Ah, man. Anyway. We'll go through and let's do calculated engine load. We can add that just by hitting enter. APP, I don't care about. Throttle, not so much. Airflow, we already have our mass airflow there. Intake, ignition advance, And this overall list will change depending on the level of capabilities within the ECU, as well as how much HP Tuners actually supports this ECU. So for an older ECU, they're not going to have as many data PIDs as your Snap-on launch Autel would have. But for, say, an LS ECU, they've got far more data than you'll get through most generic data streams. Just how they write the software. So we can look at O2 sensors here. We'll throw rear O2. I'm not big on wideband voltage or wideband current. It changes too much to be useful for me. So I'm not going to choose that right now. Closed loop, that looks good. Short term, long term, fuel system 1 status. And exhaust, I don't care about catalyst temp. But, I mean, you can really go through, you can throw some evap in there, speedometer, control module voltage. One cool thing is this diagnostics and OBD section. If you live in an emission state, a lot of your drivability concerns, the only reason they come in is because the check engine light's on. And so a lot of your drivability diagnostics, you also want to be checking your monitors. Yeah, see PJ there. Current should be the same between all makes. Stoic should be 0 amps across the board. I defer to PJ on that. I see current, I run away. At least when it comes to wideband or AFR sensors. But here, as far as our monitor status, we can add fuel system misfire, EGR, oxygen sensor, evap, catalyst, right? We'll throw that all on there. And keep in mind, even though this is a PC-based application, so you have a lot more processing power than you would on a normal scan tool, you're still limited by the inherent update rate of the CAN bus. So only put on there what you really need. You will slow it down some. So I'm in our main channel list here, and I'm going to pull out vehicle speed. I'm going to pull out coolant temp. Intake air temp, I'm going to leave in because I can use the results of this test drive in order to perform a VE test or VE calculations after the fact. Timing advance, why not? We'll take accelerator out, relative and commanded throttle out. EQ ratio commanded, we know it's looking close to being lambda, or lambda, however you want to say it. I don't really care what it's commanding in general. For most things, it does change from thing to thing. We'll take out control module voltage. We can leave load in there. Barometric pressure, where I'm at right now, we're at sea level. I know what it is. So we've calculated, a base level of data PIDs that are going to be useful. But notice here, all our graphs are still showing a lot of stuff that we don't have tied in here. And we've got no data readings yet. We'll get to that in a second. One of the features which is easier to show you guys when it's not recording. So right now we are hooked in, but we're not recording data parameters. And I found before you start recording is the best time to go over to your little check engine light here. Click that, and you'll get a pop-up for DTCs and readiness monitors. So we're just going to click read DTCs. And being as we've got the ECU powered up on the bench, we've got a whole mess of DTCs. We do have some of our monitors are complete, incomplete, not supported. So right off the bat, one of the downfalls of this tool is it does not run mode 6. There's no mode 10. I have not been able to successfully and consistently pull up CVN numbers and calibration numbers. So there are downfalls on that generic side if you're a big user of some of the other modes. This is just your live data and your DTC modes. Freeze frame is hit or miss as well. So we can click right over to our freeze frame tab. And you'll see in this case, despite the fact that we have 13 some DTCs, we have no freeze frame data on any of them. LS series controllers, a lot of other more popular in the performance community controllers, you'll get freeze frame data. It's just better supported within the software. So that is what it is there. Just to the right of that, you'll have your vehicle controls and special functions. Once again, on this particular 09 Corolla, we have nothing. More popular controllers, we can change tire sizes, we can change gear ratios, we can calibrate speedometers. There's a handful of different things that are mainly geared towards the performance community or people who are making major modifications. So bidirectional controls, especially running off of generic OBD2, you're really at a loss there. This is a drivability, data capturing, and analysis tool is how I treat it. So let's go up to our big red record button here and we'll start scanning. So now we've actually begun to populate some data PIDs. You'll see we're sitting at -40 degrees, timing advance is 5. Got that throttle pegged out. But that's everything there. So if we change our layout here to a single pane, so just follow the tray there. Layout, default layouts, single pane diagnostics. I'm choosing air fuel ratio and then airflow grams per cylinder. I like it a little better like this. It makes better use of the screen's real estate, in my opinion. So right here, we've still got a lot of data PIDs here in the graph section that we don't have up on our main screen. So we're going to change that, and this change is applicable to every variant of the data they show. So we're just going to right click and hit charts layout. And you'll see here we've got main group headings, group 1 through 5. Each one of these groups corresponds with each one of these blocks. Right? So, you know, I like the grouping of group 5 there, long-term and short-term for bank 1 and 2, except for the fact that this is a single bank engine. So let's pull that out. We don't need it. So we go click on whatever data PID we want to take out. We go to our top bar and this remove series. So we'll remove that. We'll remove it again. We don't have injector pulse switch supported. So let's pull that out and unclutter group 4. TPS, spark, knock retard, we don't have that available. Let's unclutter again. No map data parameter. Yank that out. Injector duty cycle, yank it out. So now we've already narrowed down, made our graphs a little easier to deal with. And we can set these to whatever we want. We can set our min-maxes. We can set a, let's go to fuel trim, right? We've got a max of 25, min of -25 for graphing. Let's do a reference line, and let's do anything over 10%. So if you look down in the bottom box here, we've now got this red dotted line. Anything over 10% total fuel trim, we're going to see that line there, and it's going to give us a quick visual as you're driving down the road that, boom, I'm above my, you know, magic plus or minus 10%. So we're not going to get too in-depth into, you know, building these charts until maybe about 5-10 minutes from now. Just want to run you guys through the very basics here, and then we'll pull up actual log files with good scan data so we can see some changes. And it's going to be the same thing here with our graphs. We're going to right click, go to graphs layout, and we can once again build everything out. You know, these are the charts everybody really seems to be interested in, so we're going to build those out using a Toyota 2JZ I was working on. And then our gauges, once again, we can right click, go to our gauges layout, and modify anything we would want. So let's choose long-term fuel trim bank 2 in the lower right here. And say we want to, I mean, you can resize however you want. You can move it up, down, left, right, whatever it may be. This is where you got to spend a little time and really get everything laid out exactly how you want to do it. I mean, you probably take a good 15-20 minutes to set this up. So as you'll see, we're going to disconnect from this vehicle and we're going to pull a log file up. So we're going to open our log file and we're going to do 2JZ test drive. And then I'm going to go to my layout here and open my layout and choose my Lexus 2JZ layout that I saved. So everything's already set up how I want it. So right off the bat here, I've got my math, my load, RPM, long and short-term fuel trims, as well as total trims all set up here. And if we were to go to play, we could actually sit back and watch our gauges, which is fine. I mean, this is decent to look at going down the road. You know, it's a nice digital dashboard. Not one of my favorites in the world. Hold on, I'm way behind on the chat here. I am not a live stream guy. Yeah, this is generally what I use going down the road if I just want to get a base idea of how the engine's performing. But we're going to skip back to our chart over time. And this is the data graphing that we're all pretty much used to from the scanners we've been using for years, be it aftermarket or OE. Even being PC based, it really is, as you can see, it's not nearly as smooth graphing as Snap-on is. As much as I hate to admit that, Snap-on still kicking butt in graphing, but a fraction of the price, I think it's pretty good. And then what PJ was looking for. PJ, the speed of the graphing is a little delayed. Yeah. And yes, North Country Auto Diag. The basic scan can be used on anything OBD2 compliant. You obviously, just like anything else, when you're doing generic side of the data, there are going to be some vehicles that support more or less parameters than others. So you got to be familiar with what you have to work with and what you're trying to diagnose. But at the same time, there is a federal mandate as to certain data parameters that have to be present in OBD2. So right here, this is the one PJ was really concerned with, was setting up these fuel trim tables. All right, now these are actually pre-built in, and let me pause this here. So these are pre-built in with the calculations and all. You can modify as you want to. In this particular case, we're looking at engine RPM over the x-axis and mass airflow grams per second over the y-axis. And I mean, you guys can see right here my long-term trim on bank 1, 35%, 42%, 48%, 33%, But as we get higher in RPM and higher in airflow, we start to go to plus or minus 5, really. So we definitely know we've got some issues here, right? And it's kind of nice to see it laid out like this versus doing calculations. You know, it's watching this chart over time. We can see our fuel trim swings and all, but I don't know. This visually for me, I like a lot better. And you'll notice here how, let me pause it in a spot. This little blue box is moving around. So as we're replaying our data, regardless of where we are in our gauges, graphs, or charts, it'll always indicate to me exactly where it's running at, which is nice at times. We've got total trim, bank 1 and 2. Once again, I mean, you can see we are very, very lean until we get to the top end, where we're wide open throttle, we go open loop, and full fuel enrichment. So how to build these tables, right? Everybody's pretty familiar with setting their min-maxes, choosing data PIDs. This isn't anything crazy. Right here, like we did before, we're actually going to choose these and just right-click and choose Graphs Layout. Pardon me. And within this graph layout, we've got ones we've already built in. But let's pretend we didn't have total trim built in at this point, right? Let's build our own. So we're going to go up to our top bar here and this add graph button. All right. Got the little green plus sign on it. So we're going to add that table. Now we've got a new table at the bottom, and we can label it right away, or we can choose our parameter. So PJ, do you want to do, and this is about a 30-second delay, but PJ, do you want to do building a total trim table or a short-term fuel trim table first? Or anybody else? All right, so what we do is we click on that parameter here. All right, there we are, total trim. And now we can scroll through all of this here. We can scroll through engine, transmission, speedo, all that, GPS, G4, whatever. Takes time, but right up here, text filter. All right, so we click that and we just start typing total fuel used, total knock, total fuel mass, total fuel rate, right? Total fuel correction. Now let's try total trim. Ooh. And right here, you'll see we try searching total trim, and we've tried it a few times. We tried total trim, fuel trim. It doesn't work for us. It gives us a lot of other options, but not exactly what we're looking for. And that's because of how this is actually set up. So we've got specific parameters here. We've got generic sensors, our external inputs. We've got some transforms, which gets into some crazy stuff, where we scroll all the way to the bottom to maths, right? And within our maths, let's minimize all that for you guys again. You'll see we've got airflow, cylinder air mass, fuel flow, fuel trims, lambda and AFR, or pressure. We want to be in our fuel trims. And you'll see we've got long-term fuel trim and short-term added, bank separated, bank 1, or bank 2. So if we had a single bank, we could actually just go with our LTFT and STFT and do the calculation. In this case, because the 2JZ is an inline 6, but it designates cylinders 1 through 3 as bank 1 and cylinders 3 through 6 as bank 2, let's build out 2 separate fuel trim tables for them. So we're going to choose this long-term fuel trim bank 1, and we're going to double click it. And now it's got the equation all set up. We're ready to roll. So what's our max value going to be? You know, where are we going to start to draw the line? I'd say we'll do 25 as our high value. And if we click on this color box here, we'll set that as red. Because if we're above 25, I mean, we're up a creek. Our mid value, let's set at 10, right? It's a good mid value. It's that'll be our generic. We're happy that we're right around there. And our low will just match and do the inverse of our high. And we'll set that as a dark red as well. You know what? Let's do a lighter red for that. So now we've set not only a overall number, but we've set a visual color indication that lets us know with a quick glance going down the road, I'm way rich, I'm way lean, or if I stay with white boxes, I'm right around the middle. So for our column, our y-axis here, or our x rather, we can choose anything we want to choose. I'm just going to go with engine speed, or engine RPM rather. And I'm going to choose the SAE one. I'm going to choose SAE despite the fact that I've got all these other options. Because if we look at our channels, our engine RPM is SAE. So I know that's going to match up. Now that's going to give me a whole little spiel about, you know, sometimes it's better to use a generic sensor versus an SAE sensor. In this case, no, I know what I'm doing, leave me alone. And we can set our values. You can manually enter these if you really want to. We could do 1600, you know, variance on 400. Or we could go to another table that's already got it, and we can just copy that right into our fuel trim table. Saves us some time. And like this engine's not going to go up to 6,800, so we can knock it down to 6,000. Then we can add, we'll do mass airflow, right? We want to look at mass airflow when we're looking at fuel trims. So once again, we're going to start typing. That'll populate just like a regular search will. And we're going to choose mass airflow SAE. No, I know what I'm doing. Same thing. You can do, it's a 3-liter engine, so we can start at 1, 2, 3. You know, we'll start at, 1, 2, 3, 4, 5, 6 grams per second. And then maybe we go 10, 15, 20, 25, 30. And so on and so forth, right? We're not going to go crazy here. But we can build that out as precise or as coarse as we want. We could do intervals of 1 gram per second all the way up and know exactly where everything was at every point. Or we can do broader strokes. So let's do 80, 90, 100, 110, 120, 130, 140, 150, 160. So we've got that all built out. We can change our label to, we'll do T2, or T1 rather. And right here, we did all this work. As soon as we exit out of this screen here, hit the red X button, it will generate this, this graph. You'll actually see it right down here. It's already on the list. But you went through the time and effort. Go to your old 3.5 floppy A here. And save all graphs or selected graphs. we'll save all graphs. We'll do generic setup and save. So in the future, anytime I wanted to pull it up, I could go back to my open and pull up all different graph types that I pre-configured, which is a big win. You can get everything nailed down exactly how you want it if you spend a little time. So we've got that laid out. Let's exit out, and now let's look at T1. So let's compare T1 here. Because my scaling is different, even though total trim bank 1 and T1 here are the same, because I scaled everything differently, I can better utilize my screen space. And if we hit play, we can sit there and watch it go through all our different areas. And you'll notice here, these lighter red sections, that's because it's going below our max, so it's shading. And then everything around our midpoint, that 10%, is going to be a nice white box there. So it lets us know, quick visual, where we're at. Another one I really enjoy using is the mass airflow cylinder per air. So anybody who's used a VE calculator, especially ATGs, you may often see there's a little side part there that says reference cylinder air and, you know, basically measured cylinder air. We can measure that out using HP tuners, and we can compare that to that VE calculator. Now, I'm not going to build this table from scratch, but if we go to our right click and graphs layout again, we can go down to our mass airflow cylinder air, and that's yet another one of our math channels that we can use. We set our grams, we set our high, mid, and low values, and what we want to graph it against, and we can do it. So that's pretty cool, because you can see here, if we were actually to compare this to a VE chart for this engine, at wide open throttle, our VE actually is about calculated VE should be 0.46, 0.47 grams per cylinder. And so we can see right here, all these dark greens are within that specification. When we get to that light green, the lighter green even into the white, and as we transition into the red, we are actually pulling in less grams of air per cylinder than we would be expected to. And it's pretty cool, really. I mean, like I said, you can build charts for almost anything. So if I were to go to tools and our math parameters, so these are like math channels on Pico. We can build up to 10 of our own in, or we can use the pre-calculated ones. So we've got one for airflow, where we can measure boost. And basically what we're looking at is if we have a map sensor and a baro sensor, we can do a direct boost measurement. And it's showing you the equation where it's taking map sensor and subtracting that from our baro sensor to get our total boost. Cylinder air mass. If we open this up a little bit, we can see we can run cylinder air mass, which is our reference per cylinder for a 2, 4, 5, 6, 8, 10, 12, 4-stroke or 2-stroke engines, actually. They've got the calculations already put in there. So we've got data PID, mass airflow, divided by the overall evaluation here of engine speed divided by 60 times 30. If you want to know the math, there it is. It calculates it for you. It's pretty slick. You can do your VE with various engine types. I mean, You can really nail into a lot of cool different stuff. Fuel flow based off of injector duty cycle. Calculate total fueling, which may or may not be a good way to diagnose a failing or thought to be failing fuel pump if you have a manufacturer spec for what that pump should be flowing. Fuel trims, we already saw those. So we can see banks separated. So this would actually add our total fuel trims, long and short term for both banks, and then cut it in half. I'm sure there's a time and place for it. I can't think of one right off the bat. Equivalency ratio, air fuel ratio, commanded versus actual. You can graph out the error percentage. You can do your target commands. I mean, it's pretty cool. Pressure, map versus barrel. And like I said, you can build up to 10 of your own in. There's times and places for it. So let's open up a log file. Hopefully I covered that halfway decent for you, PJ. I mean, a lot of it is really just spending the time. It's basic setups, X and Y axes, and then it's dialing it in exactly how you want it. How precise, how coarse, color codes. I mean, it's fully customizable. You know, it's everything you complained about in the scanner, you can actually modify pretty well now. So let's open a log file, another one, and do, let's see, what did I take down the road? Let's take another one. 2019 Duramax. This was an idle one. This isn't a great example. Let's do this one. So we can run through, and let's go back to our standard data graph here, what everybody's used to. If you notice in the bottom of the screen here, I've got this little drag bar. So I can kind of drag this along, just like ShopStream Connect. I can kind of drag this cursor along to wherever I want to be within my overall recording. Now this one happens to be an hour-long recording. Right? So maybe I want to find a couple spots where I did wide open throttle shifts because I want to check my VE. So I'm going to go up here to my zoom out. We're going to zoom all the way out there. And we're going to drag this little cursor up top to what seems to be the highest spike on our RPM. And then we can zoom right back in, and just like ShopStream, it's going to zoom in and focus on that cursor. So you don't have to worry about losing the cursor. So right here, we've got our highest RPM. We were doing about 68. Both of our O2 sensors, upstreams, were on the rich side, starting to trend lean. Throttle was at 61%. Spark timing, I don't care about. Mass airflow, right? So right here, I've got intake air temperature. I've got an engine RPM. I've got a mass airflow sensor reading. We've got everything we need to perform a VE test here. So let me pull up ATG VE calculator. Let's drag this over, right? And let's split this screen up. All right, so we know we got a 3-liter engine. All right, and this is the ATG VE calculator. They've got a mobile app too. I use both of them. Not a sponsor, although it would be nice. We put in our engine RPM. We go to our mass airflow reading of 122.07 grams per second. We go to our intake air temperature, which was reading about 43 degrees at the time. and number of cylinders, 6, and our pressure's about right. And you can see here, using our pre-recorded scan data, we pulled up about 69% volumetric efficiency. Pretty bad. Pretty bad. But you'll notice here, this cylinder error, 0.438, is what it's actually calculating that the engine is reading versus our reference cylinder error, which should be about 0.584 grams per cylinder. So keep that in mind. It's actually pulling 0.438. It should be about 0.584. So we can then take, after using this graph to find the info for our VE test, we can then go to the graph and see right here. We are actually calculating about 0.43. And if I really wanted to prove this out, I could go to graphs layout. Let's go to 4 decimal places, right? And exit out. You know what? I don't have enough precision in my other data PIDs to take it out, but 0.43, 0.48, or 0.438. We're pretty much spot on with the calculation there, and yet we should be all the way up here. So one could say we've got a breathing fault, right? And we've kind of put, let's see, we proved it with a regular VE test with the data we collected. We proved it within a calculation for cylinder flow or airflow per cylinder on a graph. We can also prove it in our total trim numbers as well as our individual bank numbers. And we can even go further and prove that out via our O2 sensor readings in any given point. So it's really does allow you to go through and get a lot of data relatively easily, and then you can run that 6 ways from Sunday. You know, you can start running all sorts of charts. And what I guess I should have said this before. Notice how when I built a new trim table, as long as I have those channels that I was recording originally, even if they weren't in my chart here or my graph or my gauges, as long as I was originally recording them, I can always go back and build a table, a chart, a gauge off of them. Which is really, really nice in my opinion, because sometimes, you know, I'll set all this up, but I won't feel like making tweaks to my graphs until I get back and know whether or not I want to go further into it. So it's pretty cool in my opinion. It's similar to the eScan. Like I said, it does not have a lot of the other generic functions the eScan has with your mode 10 and your mode 6 and the catalyst efficiency. But a lot of that, if you do a little research and figure out your equations for them and figure out how they're modeled, even down to oxygen storage content, you really could run a colored graph like this for oxygen storage content using equations you build your own. Like I said, it's a lot like Pico running your math channels. If you can think of a math channel that you can utilize generic OBD data for, you can build a graph for it and see things exactly how you want to. So, been rambling on for a while. Chat's not real super busy here, so what else do you guys want to know? You guys want to see a little bit of the VCM Editor side where you can actually pull the tables from vehicles? Because you can do some cool stuff with that as far as learning. I mean, it's up to you guys. I ramble on. Like I said, I'm only going live on this because I buggered the video up like 2 times trying to record it. Not trying to subject everybody to ongoing pain and suffering. Yeah. All right, well, we got at least one person who wants to see the VCM Editor, so you guys are in for some fun. So let's let me do this. Let me minimize that. Open up my VCM editor. And we're going to drag our VCM editor right over. All right. So right here, and we should be able to do this actually. Let's go through. Very similar layout. Instead of a car icon though, we've got a little, actually looks like, didn't notice that before, it looks like a little EEPROM chip. Let's try read vehicle. So we hit vehicle reader, and first we're going to try to gather the info to see if this is a supported controller. So right here, it does recognize the VIN. It doesn't recognize the hardware, and this is where you will run into, within all these hardwares, these are very common modified performance ECUs, things a lot of people are doing. Not a lot of people are modding a 09 Corolla with a 1.8, at least not that I'm aware of. But what we can try to do, seeing as we were able to gather info and it could pull an operating system, let's try to read it. It's sitting here on the bench, see, and we skipped because we didn't designate a hardware type, so it wasn't sure how to decode it. But that's all right. We can go up here, we can go to open, and let's do, all right, we got a 2019 F350 with a 6.7 Power Stroke in it. Had a tuner on it. And right here, oh, PJ, I thought I sent you pictures of this Lexus, PJ. This has got the cold air intake. This is the Paul Walker special. I'll put it that way. Like, this totally could have been a background car for the Fast and Furious 35. This was the stacked floor mat one. If it was at a Toyota dealer, you guys would have notated that on your work order. But right off the bat, you know, we're just in the engine tab. And engine size 6.7 liters. So say we were building this engine out, we bored it, stroked it, whatever. We could modify right here the engine size to account for that. We could go into, let's see, idle speed here. So some of this is just, you know, little ins and outs. You can turn your auto shut off on and off. You can look at airflow. So let's look at our MAF calibration table, right? So we've got a table here. We got mass airflow reading, and it's basically our frequencies. This one's not super exciting. Let's see if I can get a little better graph going on here. I haven't gone through all of this yet. So, calculated airflow here, engine torque versus engine speed. We could go through and actually really start to look at some of the tables, look at how they're calculating based off of engine torque and engine speed, what their expected minimum airflow would be. You can do your fancy 3D graph here. You can do your regular table. You can do a 2D chart. And, you know, this is more for tuning guys, but there's some stuff here where you can actually, if you're not familiar with that engine and you want to know, you know, what would be a reasonable mass airflow sensor reading or a reasonable injector on time. If you've got either you previously downloaded these calibrations or even on the vehicle in question, assuming it hasn't been tuned, you can actually pull this up and look at what the factory charts are. And sometimes that can actually give you a little bit better idea of really what you're looking at and what the software is looking for. I mean, there's injector quantity to pulse width you can do. where you can literally, like I was saying, look at, if I can get this lined up right, we can look at a map of our fuel rail pressure versus our injection volume and really be able to figure out how long our injector should be open at any given load or anything else. You may not always find that data, and you may have something right on the edge. Now, this is going to be more of a rare use case to really dive into something, or if you just want to learn how they're setting up these tables, setting up these maps, and figuring out what's going on with it. I mean, to me, it's kind of cool. I spend some time just looking through, trying to figure out how they calculate what they're looking for. It's, I don't know, I find it fascinating in my own way. And of course, you can get into engine diag, maximum allowable differences. You can set voltage specs, max mass airflow. So we can actually look at, in this case, it's kilograms per hour. You can change your conversions on those. But what else can you do here? Let's exit out of that one. Or the one everybody always asks about, and you can't do it unless it becomes an off-road vehicle only. But there is the ability to go in and play with data PIDs. Change them to different, or DTCs rather, I'm sorry, not data PIDs, DTCs. And change them to various states of on or off, etc., etc. 1 trip to 2 trip, 2 trip to 1 trip. And as it says on the bottom, tampering with emissions control devices can be illegal. Check your local NEPA rules and regulations. That's my disclaimer there. But, and Cody actually ran into this not that long ago. Cody Gaddy ran into, actually twice now, 2 separate GMs. One was tuned and had a lot of stuff taken out, wouldn't set readiness monitors. Another was converted from a hybrid to a regular gas job. HP tuners pulling this side of it would have helped him a lot at that point, especially with the second one, which really at the end of the day just needed a VIN rewrite in it. Could have saved him a lot of time. He could have downloaded this flash out of that controller, changed the VIN to the correct VIN for the vehicle, put it back in, and it would have been good to go. That does require credits. That's beyond what I'm familiar with, but yeah. So that's a real basic run through of some of the capabilities of HP tuners with the VCM Editor and the VCM Scanner. And I mean, you can actually go through and you can build volumetric efficiency tables. So you could go through and essentially pull out, as long as you had the stock programming, you could pull out these charts and take some of your charts and actually put them back into the VCM scanner in a math channel to build a real-time 3D, or I'm sorry, 2D, but a real-time volumetric efficiency table that would graph out similar to this one. Can't do it easily on everything, at least not that I've seen yet, but I don't know. I thought that was yet another cool option and something that's pretty convenient, as long as you don't mind throwing a laptop in the passenger seat when you go for a test drive. So, yeah. I can't believe that many people actually hung around this long for this. Questions, comments, really amusing insults? I'm just going to awkwardly wait here at this point. All right, well, I'm not seeing anything popping through. Okay, yeah, PJ, I did touch on that briefly before, but we'll do it again. I got no problem on that. So we're going to close this log file out in the VCM scanner, and we're going to reconnect to that 09 Corolla, right? So we're connected to the 09 Corolla, and we know we've got a bunch of fault codes because it's not hooked up to anything. We go right to this Diagnostics and Info tab. And yes, James L., I am using the MPVI 2. I do not have the original MPVI. By the time I purchased HP tuners, it was on the 2. I went with that. I did not opt for the Pro Kit with that additional 4 analog digital input. I didn't feel the need for it at the time. So yeah, PJ, back to that. We go right to this check engine light button here, and we click on that. It's going to bring up this Diagnostics and Information tab, and we're going to click Read DTCs. So right here, we'll see, because of all this stuff, yeah, give me 1 second. It's the Go Diag breakout box, but right here we've got them pulled up. So let me do this. How am I going to do this without making a big old mess? There you go. So, and bear with me for the delay, because I'm not sure if you guys can see it or not. Let me try this. Alright. Oh, man. This is the Go Diag setup. You can see we're all pinned out in the ECU here. And actually, since we're done with the ECU for now, or for tonight, let me just unplug that. So, controller can go off to the side. So the Go Diag is a pretty nice breakout box. It's I got it for about $100 on Amazon. It is bigger than the AES Smart Bob. It's definitely bigger than the Power Probe one and some of the other breakout boxes I have. But one of the things you'll notice here, it's got a shorter cable setup. So both of these are equal length, but they are a little shorter. I'm kind of not a fan of that, to be honest. But you got that there. You got comes in. Then you've got a 12-volt DC input onto this, and that's what actually powers this up on the bench. All right. On the other side, you've got this connector. And this is going to go out to your breakout leads. Now here you've got your standard breakout box setup. Banana jacks all the way through. You've got your lights. You got a voltage readout. Got your main power switch. And then 30 and 15 power switches. Which these two only come into play when we're dealing on the backside here with the breakout leads. So with these breakout leads, and I kind of sorted through them a little bit here. Right here, we've got various terminal sizes. Oh, man. So these are all 12-volt feeds. And you'll notice some of these, if I can focus, 12-volt 30. And we've got a fairly big end on it. 12-volt 30 with a smaller end on it. So there's two main ends, and everything on here is labeled. You got big and smalls. The 30s are obviously turned on by switch 30. The 15s are turned on by switch 15. We've got both a large and a small terminal for can low, a large and small terminal for can high. The purple here is our L line, if we were communicating on that. Green, K line, once again, large and small. We've got multiple grounds. including regular ground and OBD ground. And then those are our browns, and then our yellows we've got are all specific OBD pins. Pin 12, 13, pin 3. So if you have something that's not directly off of one of the other pins, some proprietary stuff, you can pin that out as you would need to. Or if you're dealing with a vehicle where maybe you want to put two controllers on the bench, right? Between these and your terminals here, you can actually run jumper wires and get more CAN channels available if you would want to do it that way. So yeah, it's pretty cool, and for the price, I mean, I'm pretty impressed with it. Any other questions? Or have I done a pretty good job of making a fool of myself? Ah, man. Oh, yeah, PJ, real quick. Like I was saying earlier, I find the best time to pull the codes is when you connect to the vehicle, but before you hit the record button up top here. I guess it's just the way the software is written. Corey. Yes, I can start over for you, Corey. Yeah, if you pull these DTCs before you hit the record button, I've got like a 99% success rate for whatever reason. If I start recording data parameters and then try to pull the DTCs, it either will not pull any, or I'll have to click the button 3 or 4 times to get it to read. And like I was showing earlier, some controllers, I can pull freeze frame out of it real easy. GM pulls freeze frame. Toyota, not so much. It's all based off of the level of support on the hardware, the age of the hardware. Actually, believe it or not, this Nissan 07 Nissan Altima had a little bit more capabilities on it, but PJ wanted to see a Toyota, so I just threw this up against the wall. So now it's actually throwing it against the wall probably fixed it. It is a Nissan, but yeah. So that's that. That's the basics of HP tuners. I mean, you can spend a lot of time building a lot of stuff with it, getting everything configured exactly right. So what I would recommend to do is, one, for the price, I mean, if you're doing a lot of drivability, I think for the price, it's well worth it. And if you ever run into stuff where you want to do VATS deletes, stuff like that, you do have functionality there. If for some reason you want to get into tuning, that's a possibility. You can also have stockpiles and bench flash and ECU to get somebody rolling, whatever it may be. But it's like any other tool. It has its plus and minuses. There are some really well supported controllers, some controllers that aren't supported nearly as well. The data update rate isn't perfect, but for 99% of the time it's great. Easy to save log files, highly configurable. For the price point, I like it. I mean, would I recommend this as your only diagnostic tool if you were just buying one thing? Absolutely not. You can get other stuff for $400 that'll give you modes 1 through 10. You know? So it's just another tool in the toolbox, and for the price, I think it's worth it, and I've been finding more and more capabilities for it. So to each their own, but I like them. All right. Well, I think that's about as good a time as any to wrap everything up, right? Everybody cool? Everybody's... I'm in PA right now, and we are currently awaiting our 11 to 15 inches of snowfall, which I got maybe 2, if that, right now, so should be a fun night. Yeah, Brian, the OTC 3415 is a good one. PJ, another thing I will say, and I probably, yeah, you know what? I do have one sitting here. Hold on a second. Alrighty. So the Go Diag is a great setup, except for one thing. You'll notice, and Perkins pointed this out in a video recently on his website. The Go Diag, you'll see the voltage at 11.9, 12, 12.1, 12.2. I don't like that. It's a little low. I don't know how. I mean, if Perkins is bench flashing with it, it can't be that bad. But I'd like something a little more stable, a little better voltage. So, if you know anybody with an old desktop or an old emissions machine, if you go in there, you can actually pull out the power supply unit. So, real easy, you pull the case, and you'll see your old standard 110 plug there, right? Whatever module box has that 110 plug, yank that out, and within there, you'll have a power supply. And this particular power supply has a maximum output of 25 amps for 12 volt, 5 volt, so you can build 5 volt reference. It can do up to 38 amps on the 5 volt circuit, 3.3 volts, ground. So you can, most people throw these desktops away. You can pull the power supplies out of them and have a great benchtop power supply, not only for flashing modules, but also for just playing around, fixing boards, doing various things. Instead of spending a couple $100 for a bench power supply, you can recycle an old computer, make your own out of it. This is out of an old emissions analyzer machine. I've got another one out of a Dell Optiplex. Both of them I've started tearing down. I haven't had time to rewire them and get them set up exactly right, but the ATX power supply. You can find 1,000,001 videos and write-ups on how to properly, basically just connect a few wires together and you've got a great automotive benchtop power supply. So I'll throw that out there for you guys as well as a parting gift. Like I said, that's my main negative on the Go Diag. I don't like how low the voltage gets. So the plan is to take that power supply, wire in at least one banana connector to it. But I don't know if I'm going to go through the regular 12 volt DC input or if I'm just going to jump it through the banana plugs. I have to take it apart and see what the voltage regulation's like. The heat's fine, PJ. The cold's not too bad either, but we're not like Wisconsin cold. All right, well, I'm going to let all you guys get some rest and whatnot. Tomorrow is Monday. I'm sure we've all got all sorts of fun stuff planned out. I appreciate everybody hanging out and watching me bumble through this. It is way easier to just show up on somebody else's live stream, I'll tell you that. This was like actual work. Corey, what do you mean if any mobile gets done? You guys are, I'd say like the post office, but no, you actually work and get stuff done. You know, don't you have some postman's pledge or a diet or Staten Island Express pledge that neither rain nor hail nor sleet or fire or Anything else keeps you from getting the job done? Sadly, I'd watch that, Corey. I'd watch you drive around in the snow. It's better than half the stuff that goes on anymore. All right. Let's. Shops are always open, Corey. There's always at least one person like me who would rather brave 2 foot of snow and go into work than sit at home and not do nothing. Good to see you, Brian. And I don't want to sound trite, but I do hope things start to get better for you. I know you've been through a lot recently, so take it easy. You need anything, you got the whole industry, whole community here. You've got a great network, so anything you need, you want to talk to anybody, whatever, don't be afraid, man. It's terrible, but it does get easier in time. Right. All right, everybody. Y'all have a good night, and we will catch you on the next one.